is make a short video on exactly how to use Snakify. Now, you know that we use this metaphor of learning any applied math discipline like programming and software engineering. We make a metaphor of that and compare it to making souffles or learning how to cook some food, right? And what we normally say is that when you want to become a master chef, and let's say you want to really specialize in souffles, the way you do it is there's a three-step process. Number one is you start to read a bunch of recipes to see exactly how to make a souffle. But then number two is making a bunch of souffles to get really good at it. And three, the third step would be where you become so good that you start to innovate new recipes. And the equivalent idea on the applied math computer science side would be number one, learning the theory. Number two, applying it and coming up with a bunch of computational solutions. That means doing a lot of programming. And then number three, doing research and innovating new algorithms. Now, how does this apply to what you're doing in our class? Well, if you ever sit there and you are faced with the situation where you read the book and you completely understand everything, and then suddenly you're given a problem and you're like, holy cow, I don't even know where to start with this. I totally understood what I was doing when I was reading it, but now, given the situation on an exam or a novel problem, I don't even know where to begin and I'm totally stuck. Well, if you get that feeling, what that means is you haven't made enough souffles. You haven't practiced enough. It's like reading a recipe book and saying, oh, okay, I understand what goes into a souffle. And then someone gives you a bunch of ingredients and says, make the souffle. And then you have to figure out what kind of pan to get. You don't even know how to start. You're like, I don't know what kind of pan I need. You don't know what kind of measuring instruments you need. You don't know what kind of other appliances and mixing components you need. You're completely stuck. But once you start to make a bunch of souffles, the first souffle you make will take a long time and you'll mess it up and it'll be very frustrating. But by the time you've made your 10th, your 20th, your 100th, your 1000th souffle, you will have become an expert at it. And then when someone says make a souffle, you'll make it up in a snap and you'll be like, oh, there's no problem to this at all. The exact same idea applies to software engineering and programming. There is only a very small percentage, something like 0.0001% of us, and I'm making up that statistic. But as Homer Simpson so wisely said, you can make up statistics for anything. 70% of the people know that. And so about 0.00001% of us are born with the neural networks that are already set up to allow us to program. The rest of us have had to learn it by making a lot of souffles. So how do you go about making souffles? Well, the first thing you do is you go to the theory. So on Snakify, here's lesson one. We're in lesson one. And the very first thing we see is a bunch of theory stuff. As you scroll down, you can see that, okay, the first thing it tells you is it explains the different sections. Here's section one, here's section two, and then I guess that's the end of the sections for this one. And in section one, it starts to explain some of the fundamental ideas, like the print function. And then it also gives you a sample program. And the sample program you can run. It has a built-in IDE. It has a built-in interpreter for Python. So when you click run, it executes it all. Not only does it execute the program on the input and give you the output, but you can also go step by step so you can see it executing each line. And so as you say run, you can then step through and see that it's going to go to step, that's when it's executing line one. You can see that's what happens when line one is executed. Then you press line two. That's what happens when line two is executed. Then you can press 3 and say go, and that's what happens when line 3 is executed, line 4, and so on. You can click forward, you can go backward, you can go to the first, and you can go to the last. This is an excellent way to trace through the program and see exactly what's happening line by line. So, what I would do is I would highly encourage you to, in each lesson in Snakify, to first go through the theory, read it, and then be involved with it. Step through each line so you understand exactly what it's doing. This is an active involvement with the content, not a passive reading of it. So you're not just sitting there reading the recipe book. The recipe book, as you read it, you're making your first souffle. So you're learning, oh, I better go grab this kind of appliance. I better go grab this kind of pot or pan. So that when you're faced with another problem like that, you'll already know exactly which kind of pots and pans to grab. And so you won't get that feeling when you're given a problem on an exam of, holy cow, I don't even know where to begin. You'll immediately have an intuitive idea of where to begin. So the first thing to do is to go through the theory section in each lesson and go through all of it. Once you've gone through the theory, then there's another section called the steps. The theory is like the recipe book. The steps is like the individual parts of a recipe. Which pot to get, which pan to get, which measuring instrument to get, which appliances to get, how to use the appliances, where to plug them in, what are the safety standards, all of that stuff. In this case, the steps are broken down into 24 steps. And similar to the theory, it starts to explain what's going on, and then you can actually run it and see the result. And you can see the result down here. And if there were multiple lines, you could again step through it step by step and go through it. And what you should do is go through each one of these steps. Now that we've run this first program in the step, it says, hey, you're ready to go on to the next step, and that's what you should do. Click on it, and you'll be able to go to the next step, step 2, and you should read through step 2 and then actually execute it. You can type in the code here as well that it wants. So, for example, something like this. I think that's the last one it wanted, but you'll get the idea as you go through it. And then when you're done, and it tells you which parts of it you've completed, so you should go through and finish all the parts of it. And when you have, then you'll go on to step 3, and then you'll go on to step 4, and all the way through step 24. Once you've done all that, now you're ready to tackle the problems. So the problems are the ones that are also summarized here. You see it over here. That's the same one over here. The first problem is a sum of 3 numbers. The second problem is Hi John, and that's what you see here. You can click directly into the problem, sum of 3 numbers, and what it gives you is the requirements for the program that you should write. In this case, it says, write a program that takes 3 numbers and prints their sum. Every number is given on a separate line. And you start off by having a sample where it shows a program that reads 2 numbers and prints their lines. And you see how it's doing, reading the numbers and printing it out. And then it says, can you change it so that it can now read 3 numbers and add 3 numbers in there instead? And when you're ready to test out what you have, by the way, it does supports different languages like JavaScript and Java as well, but we're going to stick with Python for now. And when you're ready to test it out, you'll click Run. And what it'll do is it'll take the input that's here, the 3 numbers, 2, 3, and 6. Right now, it's only reading the first 2 and 3, and outputting 5. So it's incorrect. It has other test cases in this test suite, and you can run them individually, or you can check all of them at once. And you can see it fails because right now the code just reads the first 2 lines, and instead of printing 11 for the first test case, prints 5. Similarly, for the second test case, instead of printing 320, it prints 20 because it's just reading the first 2. And similarly, for the third test case, it's printing out 175 because it's only adding those 2, not 158. Once you modify the code and then run it, and then check the solutions, it should then pass if you've done that correctly. So those are the 3 steps that I would recommend for Snakify. It's an excellent tool. It's one of the best ways to learn how to make souffles, which for us is how to write programs. And it's based on reading the recipe. That means understanding the theory, figuring out how to cook and implement that recipe, how to actually make the souffle. That's the steps where you go through and figure out which pots and pans you need, what the appliances do, and then testing it out by actually making a bunch of different kinds of souffles on your own. These are the problems that you have. So hopefully that helps give you a little bit of insight. If you're faced with the problem of you understand what's going on, but when you're given a problem, you draw a blank or get stuck or don't know how to get started with it, all that means is you need to make a lot more souffle. You need to literally write and solve hundreds of programs before you get comfortable with making your own souffle. So, best of luck making those souffles, and I'm looking forward to trying them out one day. Really pushing that analogy, but I'll see you all next